Hello, welcome. I'm here with Alice. Hi, Alice.
Hey, Whitney.
We're here today to teach and learn. She's going to teach, I'm going to learn about Emissary-ingress. I'm so excited to tackle the Ingress hill. But before we start, I have a joke for you. Are you
Okay.
ready? Yeah. What do you call two women in tech?
I don't know.
Friends.
Is that a joke?
I guess not a joke. It's a riddle. That's a very engineer answer. so, so it's such a gift to have Alice here today, and she I think I said you're a maintainer on Emissary-ingress, and we tell us about yourself, please.
Yeah, thanks. I'm Alice. I am a maintainer of Emissary-ingress. I am currently working for Ambassador Labs, and we're most of the maintainers of Emissary-ingress right now because we use that for our, we build some software on top of Emissary-ingress. So not probably going to talk about that today, but that's how I got involved with Emissary. Yeah.
Cool. And didn't you say you maintain another project too?
Yeah, I also maintain Envoy Gateway. So I know you've covered a bunch of CNCF technology here, right? There are two main ingresses that are CNCF designated projects, and those are
Uh-huh.
Emissary-ingress and Contour.
Mm-hmm.
And some of the folks from Ambassador Labs and some of the folks from Contour got together along with some other people from different companies like Tetrate and stuff. And now I've got folks like Tencent joining in, and we were all just like, there are two CNCF Ingress projects, and there are plenty of other Ingress projects out there that aren't even CNCF.
Uh-huh.
So let's just like bring in all of this expertise and try to stop duplicating a bunch of this effort across the board and just come together and like from the ground up design something that's going to be like powered by Envoy proxy, like a bunch
Okay.
of projects already are. And then we'll take like the learnings we had from each of our individual projects and discuss like how to build this new thing from the ground up. And then the idea is that everyone can sort of like share Envoy Gateway as like a framework to build their own proprietary tools on top of.
I love it. So it's similar to like the OCI container, the runtime spec
Yeah.
for, yeah, cool. It's about time. Part of what slowed my Ingress learning, I think, is to be like, even on the Kubernetes page to go to like Ingress controllers, and there are like 30 of them listed. And like, is a gateway the same thing as an ingress? And like, what are the differences between these things? And some of them say envoy, and some of them don't. And what even is that? And so many questions. And like, how do you? So
That's a
I'm just
good
like,
question. I don't actually know the answer to that. If I mean,
which one of those
technically,
seven questions?
if an ingress is different to a gateway, I mean, there is like a Kubernetes concept of like an ingress resource. So in that sense, they are different, but there are
Uh-huh.
plenty of projects that do the same thing as Emissary that call themselves gateways, that call themselves ingresses. Like our first
Yeah.
official title for our project was like it's an API gateway. I think both of those things like accurately describe what they do, but I think people just kind of choose which label they prefer.
This whole show is already worthwhile for me just to know that ingress and gateway mean the same thing. Because in my,
I
this
mean,
is going to be
it's
great.
mostly
There's
just
so much to
describing
untangle.
what they're doing, right? It's just like it is letting things inside and sending them where they need to go.
Yeah. And then I'm interested in like, well, similar to what you said of duplication and effort, like it seems like a pretty simple concept. So
Hmm.
then why are there 30 different projects when I go to that page that doing it, you know?
Yeah,
What's different? What distinguishes, like what are the things, the factors I'm considering when I'm choosing which one of these technologies to
gotcha.
use?
So I
Yeah.
guess to start with, there
Wait,
are,
we're we're
yeah.
we're uh we're jumping into the juicy bits maybe too soon because I'm on the wrong side of the light board. So
Oh, no, no, no. I wasn't going to get into the
okay, then bring
implementation
on
specifics,
bring
but
on the tea.
so
Let's
you have other projects that are not Ingress related that solve
uh-huh.
different problems. And I'd
Okay.
say, just based on my opinion, a lot more of those are based on like special sauce or proprietary things. They're solving problems that no one else has tried to solve yet. Whereas an
Okay.
Ingress is a well understood problem that existed even before Kubernetes, right? So you have
Okay.
traditional like reverse proxies like Nginx.
Uh-huh.
It's been around way before Kubernetes was even a thing. And it is well understood that once Kubernetes came around, we're like, we want the same kind of functionality, and now we want it to be like Kubernetes native. So
Okay.
that's kind of like where a lot of these projects started. Is a bunch of people saw a gap in functionality, and they were like, we can make this better than the out of the box experience. And
Uh-huh.
it was not a novel problem to solve, so
Uh-huh.
everyone got at it. And they are ingresses are sort of a dime a dozen nowadays. So I'd say
Mhm.
when you're picking the one you want to use, just make sure you're picking one that's like battle tested in real environments and has a configuration that you like, and then also um, has a good community behind it. Because you're probably never
That
going to
makes
win
sense.
in a feature war between ingresses because there're just so many people working on them that
Mhm.
most of them have the same feature sets.
Okay. So basically, you have people who see a problem, and instead of looking about whether a solution already exists, they decide to make a solution, and therefore, then we get the 31st Ingress Gateway project.
Exactly. It's like, hey, we've got 15 competing standards. Someone needs to come around and create a new standard to unify them all. And, like the XKCD comic, it's like, hey, now there's 16 competing standards.
Yeah, that's amazing. Great. This is already so helpful. This conversation is amazing. But let's start working our way to behind the board.
Sure.
I think I want to put in some links in chat. I'm going to put, of course, like a link to Emissary. But then you kind of started talking about community. Oh, I have a quick question about our past conversation.
Mm-hmm.
Where does the API gateway thing, the standardization that you're working on, how does that relate to the 30 different projects I see on the Kubernetes Ingress page?
Oh, you mean
Shouldn't
why
be
are we
that big.
making the 30-second project?
I've heard about this API gateway thing before. It seems
You
like
mean
a good
Envoy
thing.
Gateway or just API gateways in general?
Oh, I think maybe I had Envoy Gateway
Yeah,
confused
Envoy
because there
Gateway is the
is.
name of that specific collaboration project. But API
Okay,
Gateway is more like what type of a piece of software it is.
okay. And and then I have another question.
Mm-hmm.
What does it mean that you and Contour are CNCF? Like, does that mean you're superior, or does that mean you applied to be in the CNCF and
Yeah,
other
we
projects didn't?
applied to
Or
be in the CNCF. So they have some rules you have to follow. There's
uh
like a
huh,
CNCF conduct for how you need to operate and, treat each other and respect each other and how you have to manage the project. Another thing is it kind of helps to prevent one company from really monopolizing the project and not allowing anyone else in and things like that. So technically, like Emissary-ingress existed before we donated it to the CNCF, and we called it Ambassador API Gateway because it was just from Ambassador Labs, and then it was just like our thing, and we owned it, and we wanted to be a CNCF project. So we donated the code to the CNCF, and it got its own repository, and we changed its name because the CNCF owns the name as well. So you would lose your company's name if it was tied to whatever your company's name was.
And that also discourages you from, you want it to be open to everyone once it's in the CNCF, as you were just saying.
Yeah, and so CNCF also has different levels of designation for the projects. So that helps give people who are looking at these projects an idea of what a larger group of people have kind of agreed upon is the maturity level of this project. And so there are various different stages. There's like incubating all the way up to graduated, and things like Linkerd and Envoy Proxy are considered graduated projects, and that is saying that they are of the same maturity level as Kubernetes itself, essentially.
Okay, cool. And so is it hard to get your project accepted to CNCF, or do some people just not want to do it because they want to keep more control over it?
I don't know. It's probably a mix of both. Emissary was being donated to the CNCF. I was already working at Ambassador Labs, but this was before I joined the engineering team. So I know there were a bunch of hoops to jump through and stuff, and things that they had to get approved and all sorts of stuff that had to be done with like the code base and whatnot. But I wasn't really involved in those efforts myself.
So I could see if I was choosing one of the 30 projects to be my Ingress, I could see like that CNCF would carry some weight for me, I think. Yeah, that seems important. We have some folks to say hello to. Lisa's here. Hello, Lisa. Thanks for coming as always. And Steve Dodd, hello. And Abhishek's here. Hey, hope you didn't miss much. Abhishek, we just jumped right into the meat today. I didn't even talk about her beautiful pink color scheme. Like none of that fluff. We just jumped right into Ingress stuff. So it might be interesting to rewatch later if you have a wild hair and want to do that. So we started talking about the community behind Emissary-ingress. So I'm going to put a link to that in the chat right now. And I also think this is a good opportunity to say more about your journey and how you got started. I've been told, and it has also been my personal experience, but I've been told there are very, very few female maintainers in the CNCF and CNCF projects. Has that been your?
That is correct. In fact, the only other person that I know of, personally know, is Alyssa Willick in the Envoy Proxy project. The rest are, I know there are other women maintainers, but it's like you said, it's a lot more rare.
Yeah. So how did you get to be a maintainer? What's your story?
So I work in Ambassador Labs right now, and they mostly pay me to work on Emissary and some other stuff like Envoy Gateway. And I started off working at Ambassador Labs straight out of college. So that was my first job. That was my first job. And I was actually started off on the support team. So I graduated right at like peak COVID, and it was kind of hard to find a job because everywhere just suddenly was trying to figure out what they wanted to do with the whole working from home and transitioning a lot of these companies to like, hey, are we going to keep hiring people? Like, what is this economy going to look like with COVID and everything? So I was just jumping at anything I could find. And I was so lucky that the head of people from Ambassador just randomly found my LinkedIn and reached out to me. And she's like, hey,
nice.
We would love you to apply for this support position. And support wasn't, what I wanted to do full time, but I knew that it was a technical enough role with this specific one that it could give me a platform to move on to engineering. And
nice.
So I was in the support team for a year, and it was a lot more technical than a lot of other company support teams might be. Like you're expected to like kind of dive into the code base and do a lot of debugging and helping customers and writing up exact steps for how engineers should fix bugs and stuff if you're able to. And I found myself given a lot of freedom to go and learn the product in and out. And I eventually got to chatting with some other folks on the engineering team. And as customers started submitting some bugs and stuff, I was like, hey, I can just, write that feature, fix that bug myself. So
Oh, heck yes.
I did
I
that
love
because
that.
the code was all open source. And then I would go and bug the engineering team. And I'm just like, hey, like, I know you're super
Oh,
busy, but like, I know you guys don't have time to work on this, but I fixed it. So could you like look at my PR? And
oh.
that's how I sort of started interacting with them. And then one of the engineers on my team, Flynn, actually kind of helped make the case that they should hire me into the engineering team. And so that's how I got to switch teams. And I've been loving it ever since.
That gives me goosebumps. It's so wonderful. And we even have a comment. Alice's story is super inspiring. It's so inspiring. I think I admire you because it's really scary to put yourself out there and just make code changes and get someone's attention to look at them. And so I think it's awesome. Like the initiative that you have is really impressive. And then I never really put together that like working on open source, like you can, therefore, no one can tell you no when you make code changes. And so working on open source is a great way to get your foot in the door with people who might want to hire you later. So
Yeah.
that's just
It's
really,
also like really
really
awesome to
impressive.
just have it as like this sort of public bit of like a something for your resume, right? Like if you want to go and show a code example, like what's better than a huge open source project that you can just show
Oh,
them like, hey, here's all the things that I built and you can see exactly what I did. So that's
yeah.
also pretty cool.
Absolutely. So like instead of building your own little demo app on the side or whatever, you're making real changes that affect real life. That's amazing.
I do sometimes like write my own little demo apps on the weekends and stuff, but I never find myself finishing them before I start a new one.
That seems like a common thing, probably, eh? Let me get our names off of here. Uh, cool. I think this is it. We're
Awesome.
ready. So, as you may already know, I love to start this part of the stream the same way every time, which is so I'm relatively new to tech. I went to a coding boot camp, and I similarly, like, my very first job was as a cloud developer, and I didn't have any particular affinity toward cloud stuff. I just like needed a job, you know? And so I didn't, I kind of expected to work as a cloud developer for a little while and then later get back into web development that I learned in school. But I freaking love it here. Yeah,
That's awesome. I will
yeah,
say, I think that going to college is useful if you want to be exposed to a lot of different things and you're not really sure what you want to do. But some of the best engineers I know are, they've only ever done a boot camp or they're entirely self taught. So that is something that's kind of cool about this space is if you really want to
yeah,
learn it, there are so many great resources that are out there for free to help you learn these things. And like I said, it just because you went to college does not make you a better programmer than someone who actually is just really passionate about it.
yeah, yeah. That's such a great point. So I think you and I have been in the field actually about the same amount of time. Maybe for the first time, might be the one who's been in the field a little longer. But but since I'm brand new to this space, I don't have any context for what things were like before your technology existed and what problem is it solving.
Gotcha. So Emissary came around in around 2017, I think.
Mm-hmm.
So this is before my time, but I have, heard the stories. So from the other maintainers. And
Excellent.
at that time, Kubernetes itself was still not exactly new, but at the same time, you didn't have so many massive corporations already moving all their infrastructure onto it. So there weren't as many battle tested solutions for these sort of things. Like you didn't have 32 ingresses at that point. And, one of the main ones that did come before us actually was traffic. And that's still one of the really popular ones for
Uh-huh.
people to get started with. I think actually if you
Yeah.
install like K3S, you have to like traffic out of the box. And so traffic already existed, and it is a good
Uh-huh.
solution, but it is more simplistic. It is it requires less configuration than Emissary, but it also doesn't
Uh-huh.
allow you to configure as many things. So for some
Mm-hmm.
people, when you get to like enterprise grade applications and
Mm-hmm.
needs, um, for a lot of them, they find that traffic just doesn't cut it. And they wanted something that was Kubernetes native as opposed to running like a traditional ingress and doing something like that.
Mm-hmm.
And so that's really what caused us to create Emissary is one, we wanted our product to be Kubernetes native, and we wanted to solve the ingress problem in a way that gave users a lot of control, but also made it really easy for you to split up the role responsibility when you're configuring it so that if you have a single developer who's just doing everything like it's a hobby project, no problem, you can do it all yourself and it shouldn't be too complicated, but at the same time, design the configuration language in a way that makes it really easy for your app developers to take over, a certain subset of things and not have to worry about the bigger picture of what else is going on behind the scenes.
Is that accomplished by having like just super smart defaults so they're knobs that can be turned, but if they're not turned, you're going to have a good
Creating
experience?
good defaults is always a challenging thing. I feel like
Yeah.
we've had so many different times where we create defaults that we're trying to be smart about, and then we
Uh-huh.
inevitably get a certain subset of users that don't like them. So
Yeah.
it is a balancing act between trying to pick defaults that are good for the most amount of people while also giving people enough control to decide what they want to do and making it
Yeah.
more or less easy to get to the state you want it to be in.
So I'm hearing you about these two personas, and they're talked about in a lot of different technologies. And
Mhm.
so there's a developer being able to control what they need to control, but also a lot of the complexity left to cluster operators.
Exactly.
I think I want to put that into a definition rather than a problem. I guess it could go in both.
Mhm.
So um, the enterprise grade Kubernetes native Ingress solutions didn't exist. Can I get maybe like a concrete example of like what actual problems this caused?
Sure. So, as someone who wants to start moving onto Kubernetes, you're
Uh-huh.
probably either going to have to choose at this point before Emissary between like traffic or some sort of solution with a traditional non-native thing like Nginx, before
Uh-huh.
these Nginx like Kubernetes native things started coming out.
Uh-huh.
And you get better performance and you get better configuration when you have something that is Kubernetes native. So these are
Okay.
like the main things to solve is how easy is it to use, how portable is it,
Mm-hmm.
and is it performant?
Okay. Cool. Okay. So do you want to maybe restate about the two personas and we'll make it okay. Before we say what emissary ingress is, let's just define what an ingress is, period. Does
Sure,
that sound good? I think that would be wise.
sounds
Okay,
great.
cool. What is an ingress?
So I guess to start off, you don't need to write this down, but for context, ingress and egress are, entry and exit is what they mean, right? So ingress is
Uh-huh.
solving the problem of entry into, in this case, your Kubernetes cluster.
Okay.
And what we're talking about entering it is traffic, like requests. So an ingress is a product or a piece of software that is solving the problem of how do I get traffic into my, in this case, Kubernetes cluster.
Okay. And okay.
There's also like a Kubernetes, native ingress resource, but let's not get
Yeah.
confused with that versus the category of products that are ingresses.
Okay, I think I already had that confused. So right now, separating those two is really helpful because the ingress object, the
Mhm.
Kubernetes object, unlike almost every other, maybe literally every other Kubernetes object, doesn't already have a controller built in. Like you have to BYO controller with an ingress Kubernetes object. So are these ingresses basically controllers for the ingress objects?
Some of them do, some of them do not. So in this case, Emissary, we have our own custom resources that you use to configure Emissary. So it's like a declarative state. But we also support Kubernetes ingress resources. We have reasons why we introduced our own resources and we think you should use them, but also there's a lot of people that may like the ingress resources. In our case, we thought the ingress resource was a little overloaded. So we sort of tried to split its responsibility into a couple different resources to make it easier to manage when you just want to do really one thing at a time.
So it could control Kubernetes ingress objects. It could make its own objects and not even touch Kubernetes resource objects called ingresses, or it could do both.
Yes.
Okay, this is so like all the light bulbs are popping for me today. This is wonderful. So solves the problem of getting traffic into a Kubernetes cluster. I think this is a maybe a good place to talk about what considerations are happening here. Yeah, cool. So what are some things? What are some of the problems of getting traffic into a Kubernetes cluster?
Geez, there's a lot of them. I guess the main things to worry about are scalability. I already mentioned performance is just like a general thing that people care about with any sort of thing, because it is your entryway to everything else that you're running in the Kubernetes cluster. So it is potentially your biggest bottleneck if it isn't performant. So you really care about how scalable and how performant it is.
Okay, I'm going to make... So those kind of go hand in hand, yeah?
Exactly, yeah. I mean, you obviously could have an ingress that has horrible performance and you could just scale it up like crazy. But we would rather if they're both scalable and performant.
I like your brain, Alice. Okay, scalability and performance, what else?
The next thing is thinking about the type of traffic that you want to let into your cluster. So on the surface level, there's of course HTTP and HTTPS. And those make up a large percentage of all web traffic, right? So that's going to be probably a lot of what most people's needs are. But there's also other, protocols and things that people want to support. There, is HTTP3, which so far has limited support. Emissary does support HTTP3. There is, proxy protocol. There are even more kind of niche protocols like Speedy or gRPC is very popular. And each of these have slightly different needs for how you handle these requests. So you want an ingress that supports all of your different needs. There's also like WebSockets and stuff, but we could go down the list for all day about like what kind of protocols people use for different reasons.
WebSockets, okay, I love it. Many more. Okay.
And then the next thing is that people want a way to manage security and they want a way to manage how that traffic is getting to their resources.
Do you think those are very related to things that are hand in hand, or are those two separate things?
Kind of two separate things.
Okay, that's what I thought too, but I just want to make sure. So let's say security. So that's where certificates are defined. I know Cert Manager can work with Ingress stuff, right?
And what security is like a multi-tiered problem, right? So there's all sorts of aspects to security when it comes to even just an ingress. So TLS certificates are, of course, the number one thing that it's just a must-have, right? But there are also other things that you might want to do, such as OAuth, right? So that is sort of the idea of each request needs to be authenticated, whether we, allow that or don't allow that based on the user's, credentials, that sort of thing. And I would personally consider rate limiting to be part of security. So you don't want bad actors or misbehaving clients to be able to, effectively give you a denial of service attack because of how many requests they're sending to you. there's all sorts of other things with authentication, but I'd say like those are really some of the main concerns that people start out with.
Okay, cool. And then the second one you said security, and what was the other one?
That's like once you have the traffic and you're able to accept it, where do you want to do with it, right?
Oh,
So
yeah.
that's making sure the traffic gets to where it needs to go. So
Mm,
maybe it's traffic routing.
great, thank you. I was gonna write it a long way. Okay. And this seems to have an overlap with networking.
Mm-hmm. I'd say like a lot of what we focus on is just really networking.
Okay. And then what kind of considerations do different ingress solutions have for traffic routing?
With traffic routing, it's a lot about, like I said, what sort of support they have. Do they support gRPC? Do they support all the protocols that you want to use? Do they
Okay.
support the kind of configuration that you are trying to accomplish, right? So some people might want to have an HTTPS request go in and have the ingress terminate TLS, and then the ingress will talk to their upstream apps over clear text. Other people might want to have the ingress talk to their upstream apps using HTTPS or even MTLS, where both the client and the upstream, verify each other's certificate. Um, those are the sorts of problems you might want to solve for. Other people might want to just send raw TCP traffic up to their upstream service or raw UDP traffic up to their upstream service. So it's all about how you want to match and manage and what exactly you want to do with that traffic, and does the ingress support the type of traffic that you want to use. You can also do sorts of traffic manipulation. So traffic manipulation would be things like editing, adding, removing HTTP headers, and that sort of thing.
You're I'm sorry, the thing you just said, it didn't hear it because I was thinking.
No worries.
Um, so the traffic type that comes in basically might not be the same type that you want to send to a service. And so that's what you need to consider here. And
Potentially, or potentially maybe it is, and you don't want your ingress getting in the way of, letting that traffic do what it wants to do.
yeah, as opposed to what types you're just letting into the cluster in the first place. I guess I'm
Yeah.
trying to distinguish how this traffic type considerations is different from traffic routing.
So, for example, you might have some people want to allow HTTP traffic. I don't recommend it,
Uh-huh.
but some people have a need for that.
Uh-huh.
Something like an ingress lets you do is automatically, when it receives an HTTP request, it'll say, hey,
Mm-hmm.
I know this request isn't secure. So it'll go and redirect that back to the client, and it won't route the traffic until it receives that request back as an HTTPS request.
Okay. 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 Cool. And what's next?
Um, I consider it kind of part of the traffic routing problem, but the traffic manipulation. So whether you want to add or remove or edit the HTTP headers. So there's
Mm-hmm.
all sorts of use cases where you might want to remove a header coming in or add your own new one that the upstream is going to make use of. Um, Other examples are like, hey, I want to actually redirect this traffic to some other place that is in my cluster or outside of my cluster. Or maybe you even want to rewrite like the host name. So if you control a bunch of domains, like really popular companies like Facebook and YouTube might want to buy up domains that are really similar to their domain. And
Uh-huh.
instead of just supporting traffic on like some misspelling of facebook.com, their ingress could solve the problem of when the client connects, it'll say like, hey, I'd rather if you changed this URL to facebook.com instead of this misspelling, but we control the other misspelled domains just so we can help our users get to the right place. So their ingress can notice when those requests come in, and it can redirect them back to the proper spelling of the domain. So that way it's all on the same domain path with what they want people to be reading on their URL bar.
Cool. This is wonderful. Is that all the considerations?
Mm, I guess, yeah, that's probably good.
Yeah, maybe all the mention worthy ones for now.
Yeah.
You can't make in this industry, you can't make a blanket statement like that is all. Uh, okay, great. This is wonderful. So we have a ton of different Ingress projects being just general ways to let traffic into the cluster, and may or may not have to do with the Kubernetes Ingress resource. And then all of them have different ways they handle all of these different considerations.
Mhm.
Great. And now we're going to talk about how Emissary-ingress does it specifically. We're back to these two personas that you mentioned. And do you want to maybe write a definition now about what Emissary-ingress is?
Emissary-ingress is a Kubernetes native self-service API gateway.
Oh, so the self-service captures the developer experience part that you want to
Exactly.
capture.
Yeah.
I see. Emissary-ingress is a self-service
Mhm.
Kubernetes native, right?
Mhm. It's a mouthful.
They all are. Kubernetes native API gateway.
Mhm.
Gateway being the same thing as an ingress, which is wonderful for
It
me
is
to know that.
a gateway for all of your API needs.
Yes. All right. So I want to write down about these two personas.
Sure.
So the apps person.
Yeah, we actually like have names for them in
Oh,
our group. So we have the idea of Jane, who is an application developer. She really mostly just cares about working on her application that is running in Kubernetes and making sure that everything is going well with it and making sure that traffic gets to her application. That's all she really cares about. The
okay.
other persona is Julian. So he is like a cluster operator. He is someone who cares about security. He cares about how everything is kind of organized and set up in the cluster and all the different rules and intricacies of how we handle things in a larger scale.
So how does the app friend interact with emissary? Or
Yeah, so like I mentioned, when you use a Kubernetes Ingress resource, we sort of felt
uh-huh.
it was overloaded because you have to specify all these rules about how exactly you want the traffic to come in, then what you want to do with it, all in this one resource. So you end up with these large bits of configuration where maybe like your application developer is just not that interested in it.
That
So
makes
in
sense.
Emissary, we split the Ingress resource into 3 tiers. There is a
Mm-hmm.
listener resource. There's you can get into these more specific later, so you don't need to draw anything. But
Okay.
there's three resources. Listener controls what we listen for. Host
Uh-huh.
controls what kind of host names we're using and what we're doing with TLS. And then you have a mapping. And the mapping is where we're sending the traffic. And that's really all that the app developer persona cares about. They don't need to
Okay.
know like what host names we're using, what ports we're listening on, what we're doing with TLS and security and stuff. Like they don't care about that sort of stuff. They just know that they want to get their app running and they want to get traffic going to it. And they don't want to sit around all day once they have, created a new app or made some changes to their app to get their cluster operators to make these changes for them.
It's
So
called the custom resource is called a mapping.
yeah, that is the specific name of it.
Okay. Cool.
So what we found is that with the transition from a lot of more kind of like this monolithic deployment architectures where people are running things on VMs or whatnot, to splitting things up into microservices and running things on Kubernetes. Um, More and more companies are starting to have this idea of an app developer should own the entire life cycle of that app, not just the
Mm-hmm.
code base, but also like running that app, getting traffic to that app, and kind of being responsible for how it behaves in production. And
Mm-hmm.
so it's a lot faster if you can allow your app developers the ability to configure how they want to send traffic to their app and just make those changes automatically,
Mm-hmm.
rather than going and sending a Slack message or opening a ticket
Mm-hmm.
to some cluster operator who's going to have to
Mm-hmm.
get through all the stuff they're working on and their priorities before they can make those changes. And maybe they find out like, hey, those changes aren't what we need, and we have to go back and test this, or the cluster operator now has to suddenly figure out what the heck is going on with this new app and what changes have been made to it. So, Jane can deploy her app and she can worry about how to get traffic to it. And that's what the mapping helps her do. Is a mapping just handles like, okay, what traffic are we matching and where are we sending it, are the primary things we want to do. And are we making any changes to that traffic before we send it there? So if you want to keep it as simple as possible, Jane can just say, give me a mapping. I want all requests on the path / backend to go to service, my service. And
Oh,
she's done.
rad. So I do want to capture these custom resources, but right now I want to finish so we got the app friend story, except we'll get a little more into the mapping. I'll capture that on the board later. And then I want to say hi to Orlin. Orlin's here.
Hi,
Hi,
Orlin.
Orlin. Thanks for coming. Orlin was a guest and taught about Harbor Container Registry pretty recently.
Fun.
And so ops folks are concerned with all the traffic in the cluster, right? And also with company best practices.
Mm-hmm.
And is there there's probably several resources that they are concerned about, but for this definition, we can say emissary offers full control over all these considerations. Yeah. Or yeah. Cool. And then, so I want to capture these custom resources. How many are there that you think are good for us to learn about today?
There's the mapping, there's the listener. So that's like what ports you want to listen on and what kinds of traffic are we listening for. Then there's the host that controls like what kind of host names are we using. So you could say like open port, open traffic on port like 8443, and allow all HTTPS traffic in, but you could say like only allow traffic that has a host name that matches one of like our domains. All the other traffic that manages to just find our IP or any other random, thing that resolves to our IP with DNS, we're not going to let in. And that allows you to do all sorts of things. Like you can even do host-based routing instead of like path-based routing. So you can say like all, traffic on example.mydomain.com goes to this one service. Doesn't matter what the path is. So that gives you a lot of control over what we do with the traffic based on the host it's connecting on.
Okay. I'm going to make you repeat some of that. I'm sorry.
All good. No worries. Just setting the stage.
Great. So first we have a mapping.
Mm-hmm.
And so tell me what a mapping does.
A mapping controls where we're sending traffic and what changes we're making to that traffic.
A mapping controls. What's the first part? I'm terrible.
Where we're sending traffic, where traffic goes.
And what was the first part?
Oh, it controls where we're sending traffic and if we're changing anything about the traffic.
Oh, got it. Cool. And what's the next one?
A listener, broadly, just configures if and how we listen for requests. So what port and what protocol we want to use.
Cool. I love that.
So Emissary by default doesn't actually listen at all for requests until you create a listener resource, whereas other ingresses might just accept any traffic that comes through to them. Kind of depends on your flavor of ingress.
What if traffic comes in somewhere where there's not a listener?
It will just have no route found. So you'll just get an empty response.
Cool. Okay, repeat what a listener is so I can write it down, please.
A listener configures what ports we listen on.
Cool.
And what protocol we're listening for.
Cool.
So as an example, you could say like, I want to listen on port 8443, but on 8443, I only want to listen for HTTPS traffic. HTTP traffic will not work on 8443 is like an example for what you might want to do.
Okay.
And then we've got the host would be the next resource when you're done there.
And the third one.
The host resource.
Gotcha. This makes so much sense.
The host resource configures what host names we want to support. So you can even do wildcard and just say every host name, or you could limit it to specific ones.
Okay.
And then it also has all sorts of support for the various TLS settings you might want to do, like what we're doing with TLS.
Okay. Also support for TLS settings. I just did a Cert Manager episode pretty recently, so I'm interested, like, is it using Cert Manager under the hood, or does it have its own Cert Manager-y solutions?
It doesn't. So the product that we build off of Emissary, I don't want to get into too much, but that one does have like Acme support. So you just create a host and it just creates certificates for you. But with Emissary, you bring your own certificate, which means you can either point it at one that was created by Cert Manager, or you create your own in your cluster, however you want to go about it.
Oh, okay, got it. So it also has support for TLS. Is there more that I should say about that?
Probably not. There's a bunch of different TLS settings that are their whole own topic.
Cool. So maybe this is a good time to draw out what's happening. So like, you agree? Okay, because I want a linear experience now. Cool. So so if I want to make a cluster for this, do you think it would be good just to have one box that represents a cluster, or should I distinguish like a control plane from worker?
No, I think just one box is fine.
Okay. And do we have a lot of words left, or should I make it take all this room?
All that room is probably good. I don't want to focus too much on the text for the rest of it.
Okay. So this is our cluster. Is there enough room outside of the cluster for?
Yeah, I think so.
Okay. Cool.
So I guess like I'll talk about it in terms of what a new user that's installing Emissary would experience. So they've got their Kubernetes cluster. And once they install Emissary, if you want to make like a box for Emissary in there.
Okay. And should it be like it's coming through, like where the box is what lets stuff in?
Just put the box on the inside for now, as its own like smaller box within the main Kubernetes cluster.
Okay. Like that?
Mm-hmm.
Cool.
Awesome. So you'll install Emissary, and it's created in your cluster as a deployment. So you got like an Emissary pod running now. And now when you deploy Emissary, if you use like our installation guide, it'll also create a load balancer service. So if you want to draw that as like a box that is on the line between the edge of the cluster and the outside of the cluster.
Okay. I'm going to write E for Emissary load balancer. Great.
Awesome. So this isn't something that Emissary has any control over, but it does create it. And what that does is if you're using a cloud provider like GKE or AKS or AWS, is they will see that you have created a load balancer service. And they're like, oh, you want a load balancer? Sure thing. And so they will spin up behind the scenes. This is all kind of transparent to the user. A machine, like a VM or something, however they do it, to handle traffic from the outside and getting it into your cluster. And then that service that's in your cluster, the load balancer service, will get assigned that external IP. And that is how the traffic enters your cluster. And then that load balancer sends the traffic, just all of it, straight to Emissary. You just draw one little line between the load balancer and Emissary. So you got your client that talks to the load balancer IP, and then the load balancer just throws all that traffic at Emissary.
Okay. I'm running out of space. So what I'm writing here is that this load balancer is created by Emissary but implemented by the cloud provider.
Exactly. We basically, when you create a load balancer service, if you have a cloud provider, you're just telling them like, hey, I want a load balancer. And depending on your cloud provider, they have all sorts of like default configurations, and you can manage that sort of stuff in your cloud provider portal. Now, if you're actually running this on like bare metal, like on your laptop or something, load balancer services don't work. So there's other ways to get around it, but that's important to know is you'd need to change that to like a node port or something if you don't have a cloud provider. So
Okay.
a lot of the magic of like what lets traffic really get in there is handled by the cloud provider, but they don't really do anything with it. They're just opening a portal for traffic to enter.
Okay.
Emissary is what actually manages that traffic once we've gotten it in the cluster. So now
are there different instances? Is it load balancing between the nodes then? Like if Emissary is taking all of the traffic, what's it load balancing between?
So it load balances between Kubernetes services, and you're not limited to Kubernetes services either. You can send traffic to just arbitrary, URLs even with Emissary and send it outside of the cluster. So maybe go ahead.
So the load balancer might say to Emissary, here's some traffic and it needs to go to this service, and then Emissary takes it from there.
Nope. The load balancer just says, hey, here's my IP address so that you do whatever you want to do with it. And I am sending traffic to the Emissary service on, whatever ports you want. And that's all it does.
So it balances between, it just sends everything to, so it's not actually balancing traffic. It's not actually splitting it up.
You have multiple instances of Emissary, right? So when it's sending traffic to the Emissary service, maybe you have multiple replicas of Emissary and it will load balance between them on the Kubernetes level. If you have multiple different nodes also, it handles the split between how you want to handle traffic across different nodes if you've got multiple different Kubernetes nodes for your cluster.
Thank you for that clarification.
And I guess now is probably a good time to mention what Emissary really does on the internals. If you want to draw another box, it's like the same shape as Emissary, but attached to it on the left side.
Okay. What will it say?
It will say Envoy Proxy.
Oh, Envoy.
It is part of the Emissary box, but it is its own process.
It's like a sidecar running in the same pod as Emissary?
Nope, it's even in the same image, same container. It is its own process.
Oh, a process in the same container as the other Emissary processes.
Yeah. So Emissary, you can think of it as like a two-part show, right? We've got Envoy Proxy, which is actually the thing that does everything we want to do with the traffic, but Emissary configures Envoy. And so the reason why a lot of people don't want to use Envoy on its own is because it is really, really hard to configure Envoy. Its configuration is totally massive. Like even for a minimal installation of Emissary, we're probably producing an Envoy config that is several thousand lines long. And that is just handling like defaults and stuff. So when you want to actually handle getting traffic and stuff to your services and doing stuff with the traffic and all that other sort of good stuff, you end up with an Envoy config that is just completely unmanageable by humans. And that is why other products like Emissary, and there are many other things that use Envoy, but don't allow the end user to configure it, because Envoy is really powerful, but it's also really, really hard to use. It's more of something that's better to be managed by machines.
That makes a lot of sense. What function does Envoy Proxy have? Are there lots of proxy choices? I only ever hear Envoy Proxy.
I'd say like the main ones are Nginx and Envoy, if we're just talking about behind the scenes. Now, there are some ingresses that choose to build their own proxies. A lot of them, actually. will
Okay.
just build their own proxy from the ground up. But the main ones
Uh-huh.
that are like really battle tested and really well known are Envoy proxy and Nginx.
Okay.
And so
And what
Emissary exists as a tool to basically manage and configure Envoy for you.
oh. Okay. So if you were, I mean, you just said it's unmanageable by humans, but
Mhm.
if for some reason like you were uh Emissary is almost like a skin for like makes Envoy proxy
Exactly.
accessible.
Exactly.
Okay. I want uh I want to write that down. Will you repeat what you just said because it was
Yeah.
more eloquent?
Emissary is a tool
Mm-hmm.
to manage and configure Envoy proxy.
And then what is the role of a proxy in a in this situation?
In this case, it is a reverse proxy, which means that traffic is all entering and the proxy is splitting it up and where it needs to go on the internals. So you might have like
Okay.
um, a non-reverse proxy, just a normal proxy, which is the opposite of that. But for this case, we just care about accepting the traffic and sending it to our own stuff on the inside.
Is Envoy always a reverse proxy?
I think it is. I
Okay.
don't know.
So Envoy proxy is basic, like it's what does all of these things. It's
Exactly.
the thing that makes the yeah, and knows where everything is and therefore knows how to send it to where it needs traffic to where
Exactly. And
everything
so
is
Envoy is
needs to go.
super powerful, but like I mentioned, there's just so much config and changing it is its own, you might have like one or two people entirely dedicated to just updating and configuring Envoy if that was how you wanted to manage it. It
Mm,
is a full-time job managing Envoy config without some sort of external tool.
okay. And then is this related to the other project you're a maintainer on? Wasn't it
Yeah,
Envoy Ingress
Envoy
or something?
Gateway is what it's
Envoy
called.
Gateway.
So Envoy Gateway is just a project where it does the same thing as Emissary. It is a tool to configure and manage Envoy proxy. But the difference is that one, Envoy Gateway is a collaborative effort between all these other projects that started off on their own. And then, we've had all sorts of mistakes and learnings over the course of our project's lifetimes. Like
Mm-hmm.
Emissary, for example, predates even Kubernetes CRDs. So there's lots of, you know, dust in the code, decisions that we were sort of forced into as a result of, early adoption phases. So
Mm-hmm.
Envoy Gateway is just doing the same thing, but it's a ground up rewrite of a lot of the different learnings from these various projects like Emissary and Contour. And there's a lot of folks on it who provide input even from like a service mesh point of view. So we've got Tetrate folks who are, bringing their own learnings from service meshes to what they want out of an ingress.
So you're creating a standardized toolbox to work with Envoy?
Exactly. And so Envoy Gateway is actually, part of the Envoy project. So it is like a first party, this is an opinionated stance on how you should manage Envoy. Other people are still totally free to build stuff on top of Envoy or use it for whatever they want. But this is sort of our attempt at working with the Ingress folks and the Envoy folks to create something that is usable by everyone and stop duplicating a lot of the Ingress effort across different projects.
I have another question. Oh, I want to say hi to Fuel Stumble. Hello, Fuel Stumble.
Hello.
Thanks so much for coming. Fuel Stumble's the best. Um, the so we're talking about Ingress, and then a lot of times we'll just switch over to Service Mesh. So they seem to be very
They're
related to
very
each
closely
other.
related.
But what distinguishes them, or
So I guess the one example I like to say is you've got an ingress which manages north-south traffic. So that is traffic into and out of the cluster. And then a
uh-huh.
service mesh manages east-west traffic, which is traffic between the different services. It's not coming into the cluster and it's not leaving the cluster. It is one service needs to talk to
Ah,
another service.
okay. Okay, I like that. Okay. I'm gonna write it down. Am I running out of space? I just want.
I don't want your head to get lost in everything.
Oh, I'll keep it over here. Okay. So service mesh um, manages traffic within the cluster.
Mhm.
So if you have a multi-cluster situation, you're just having service mesh and ingresses really tightly working together.
Yep.
Is it common for like a project to make both things so that they're being built together?
Um, Geez, I'm trying to think. I'm sure there are. I know for a fact there are some service meshes that are working on that right now, but I can't say for sure, what that's going to look like at the end of the day. I think for a large part, service meshes are just interested in providing their own offering for Ingress. It's really simple. It's not like maybe as feature rich as something like Emissary, just so that they can solve the Ingress problem for users who know they want a service mesh but aren't really sure what they want to do about the ingress problem. And maybe a simple ingress is good enough for some people.
Okay, amazing. Thank you.
So one of the reasons you might want to choose Emissary over another ingress is we actually have like built-in support for service meshes. Like we integrate really tightly with Console and Linkerd and Istio. So it's a lot easier
Yeah.
to have your service mesh and have your API gateway or ingress if they work well together.
That's exactly what I was thinking too. Fuel Snobble, I think I forgot to tell you, Alice, that we'll dance our way out of the episode.
Oh
But
yeah.
yeah, you're really small. It'll be okay. Also, it's like your shoulders and up, so you could just do like
Sorry,
a
I'm just
little,
slouching a
yeah.
little bit.
So Fuel Snobbles are already lamenting that they'll have to miss the dance, but you can you can watch the replay, Fuel Snobble. Great. So we have a traffic coming in. It hits the load balancer. The load balances between emissary instances and between nodes.
Mhm.
And then the emissary is tightly coupled. Is that correct with the Envoy proxy?
Yep,
And emissary is basically giving us a skin for that. So it's something that's human configurable,
exactly.
yeah. And then what?
And then, so the traffic is actually going straight from the load balancer to emissary, and Envoy is what's handling that traffic, right? So Envoy is
Okay.
making all these decisions. Once Envoy has been configured by emissary just kind of sits back and it just watches these resources. And then if they change, then it knows it needs to go reconfigure Envoy. But after that point where you're not making any config changes, Emissary is just sitting there and it's waiting for you to change the config while Envoy is doing all the heavy lifting of getting the traffic where it needs to go and performing all these complex transformations on the traffic and stuff. So if you want to draw like another little box out to the side, it'll be like a service you want to send traffic to, like a Kubernetes service.
Okay. So this is like our application.
Yeah, exactly.
Okay. I'm gonna put it over here. Does that make
Perfect.
sense?
Yep.
Okay.
Awesome. So you can just draw a line from emissary straight to the app.
I went through Envoy proxy. Is that all
Yep,
right?
that's perfect.
Okay.
Technically, even if you want to, that line from the load balancer, it doesn't actually go through emissary. So you can draw that line straight through emissary into the little Envoy box. Yeah, just like that. Emissary is not actually touching any of the traffic. It's just doing stuff for Envoy. It sits in the container and it just listens for config updates and builds that complex Envoy config. And then Envoy just chugs away. So Envoy is really performant with CPU resources. If you give Envoy, enough CPU resources, it can chug insane amounts of traffic without any sort of slowdowns or real latency penalties.
Which we talked about performance. So emissary, I just wrote configures
Mhm.
Envoy proxy. Great. And this is our traffic. Oh. Excellent. Is that it, or are we going to talk about how these custom resources come into play?
Yeah, let's do that. So within the cluster, you could sort of draw anyone you want, like a mapping will do, wherever you like in the
Okay.
cluster.
Okay. Okay.
And then we'll draw an arrow from the mapping to Emissary-ingress. Can go around the Envoy proxy because Envoy
Oh, a
doesn't know
different
about
color.
these things.
Okay. I love it. I love your attention to detail, Alice.
Yeah, awesome. So Emissary's main job is, it has introduced these resources which give users a friendly way to configure Envoy to do all this powerful stuff. And so Emissary just sits there and it watches updates on these resources. And once it detects like, oh, your mapping changed, it will, wake up and it will build the config over again, and it will push that config to Envoy proxy, and then you will magically see those changes happen when you send requests.
So the resources are a user-friendly way to configure Emissary, which is a friendly way to configure Envoy. And when you say it will wake up, is it like a serverless situation where there's no app running until you give it something to
It's
do?
not serverless because Envoy is always doing stuff. It's always listening for requests and it's always, prepared to handle them. But
Oh, because
Emissary,
they're two processes in the same, got
the
it, in the
process
same
is
container.
actually still active, but it's not doing anything. It has no work to do until these resources change, really.
Okay, so traffic's here, and then I like, um, okay, I want to capture like Envoy and Emissary are two processes running in the same container.
Mhm.
Cool. And then, oh, this is one of the like processes that's spinning around the back of my head is like colors and markers. For the longest time, pink wouldn't show up. I think it's, I think this new batch is better. Anyway, that's not interesting, but I'm just pleased with my pink.
By
The
the way, I love how well your green matches the little background of the green lightning bolt.
that was my design. Yep. You have your like all your pink matching going on in yours. I feel like because with the orange and green, it's like a Halloween vibe here.
Oh, really?
So,
It's nice that it looks yellow.
oh, okay, I accept that. So, I want so then human-friendly ways to configure and like human-friendly and like with persona friendly.
Yeah. And like I mentioned it beforehand, but like to give a specific example, we benchmarked it, and like a single mapping with like 3 to 4 lines of config will produce an Envoy config that is about 2,000 lines long. So
Oh my goodness.
yeah,
Yeah.
it's a little bit much for humans to manage. And then you've got like, hey, every time I edit one of these things, this Envoy config could balloon in size all of a sudden. And so it's just it's possible to manage as a human. It is like a human readable config, but it is just so big, and it's rather complex to the point where you would need someone who's like an Envoy expert and who is just constantly updating that thing to manage it without some sort of a tool.
So you said, tell me the numbers again.
I think it's like 3 to 4 lines of config on a mapping will produce roughly 2,000 lines of Envoy config. And that's just mostly us building up the structure of the Envoy config and picking safe defaults for everything for you.
Okay. So human-friendly, persona-friendly way to configure Emissary, which configures Envoy proxy.
Mm-hmm.
Are there other custom resources and you're just giving us highlights, or are
There
these
are a bunch
the only
more,
three?
but these are the
Okay.
important ones that are just like, those three are like mission critical to enabling developers and cluster operators to do everything they want with traffic. I could totally get into some of the other ones, but it looks like we're running out of board space here.
Cool. How's my face? Okay. What is there something else I should know about?
Yeah, I guess like the remaining resources are largely things where you would just kind of set up and then forget about them. Whereas your mappings, listeners, and hosts are probably going to be the bulk of your config, and they're going to be the ones that are changing, as things happen and you develop your apps and create new ones. The two main ones I'd like to mention are the auth service and auth service and the rate limit service resources.
Auth service, is that all one word? Or is it like high?
All one word.
I'm right. I'm gonna. Okay. What's the other one?
The rate limit service.
Rate limit service. And the service is part of the name of the resource name?
Yep.
Cool.
So what these things do individually is they tell Emissary, hey, I have a service and it does auth or it does rate limiting. And so Emissary will see that you have created an auth service or a rate limit service, and it will configure Envoy to talk to that service for decisions about authentication and rate limiting. So when you do that, Envoy will not let a single request through until it has talked to either or both of those services. If you have both, we set it up so auth always happens first. But that's not a hard requirement. We just made an opinionated choice on that.
So it's a way to label and configure services that you've already, like, it's not creating an auth service, it's pointing at an auth service.
Exactly. So you would write your own, you bring your own auth service and rate limit service using the API that Envoy makes available. It's actually very easy to use, surprisingly. And then you would point at that service and Envoy says, okay, there's a new request that came in. I'm going to go talk to the auth service and see whether I should allow this request or deny it. And so within that auth service, you can do things like implement OAuth and OIDC and all that good stuff. And the rate limit service does the same thing, but for rate limiting decisions. So let's say you have both of them. So Envoy would say, hey, I'm not going to let this request in until the auth service says it's okay. And the auth service will say like, yes, allow this request in, or it'll say like, no, deny this request and send them back like a 500 or like a 40 whatever error. And then that's how you handle the rejection of requests. And then the rate limit service, those are pretty easy to implement for the most part. You would just basically measure the request per second as something, and then you would just say like, hey, this request exceeds the request per second and we're not going to allow it, return a HTTP like 429 response, or we are going to allow it and it gets to go through the whole rest of the dance of all that other config we've created.
That makes a ton of sense. So I don't want this to go too near the cluster. So if these two were in the cluster, the traffic would go load balancer. Still
it would go straight to Envoy, and then Envoy would talk to those other services, back to
Yeah.
Envoy, and then to your final destination, which is your app.
So there's not room to draw it, but it would be like, let's say it's an auth service with OAuth.
Mhm.
I want to make room. So it would be a separate thing, OAuth and then auth service.
Yep. Or rather, the OAuth would be like part of your auth service. You could just have an auth service that's as simple as like, hey, like unless the request has this header, deny it. You don't have to do OAuth, but a lot of people want
Okay.
OAuth, so you can make
Yeah.
any sort of decisions you want based on whether you should allow or deny resources in your
So then
auth.
our traffic could go load balancer, Envoy proxy to auth service, which checks with OAuth. It's agreed back to Envoy proxy. Now it has a green light, and now it goes through to the app.
Exactly. And so
Cool.
Envoy's not actually sending the real request to the auth service. It makes a copy of it. So technically, Envoy's sort of like holding that traffic there and just saying like, hey, here's what I got. Does that look good to you? And the auth service is like, yep, green light, or like, no, send this back to the client. And then Envoy is like, you got it.
Cool. Great. So is there anything else you want to tell me about, or should I maybe you try to recap everything you've taught me to make sure we have a good to make sure we got it all correct?
There are other things I could talk about, but I don't think we need to.
Okay. Then not to make sure the story is complete. If there's something you want to mention, maybe I just won't write it down, or if it fits in this space.
Oh, it totally wouldn't. But yeah, I guess another thing that I should probably mention is load balancing in the cluster, right? So how do we
Okay.
send the traffic to the service? And if that service has like lots of different replicas and stuff, like how do we want to handle load balancing that traffic? So you have lots of options. You can do like round robin load balancing, or there are more complex like load balancing systems where those enable you to do things like sticky sessions and that all that goodness, or like send it to whatever service has received the fewest requests. And that sort of just helps prevent a single instance of your app from getting overloaded. And Kubernetes has that built into those Kubernetes services, right? So when you create your app, with or without Emissary, you'll have your Kubernetes service. And normally, when you're using Emissary, we just use those services to talk to. So Envoy doesn't actually know the like endpoints or the IP addresses of your app and its containers. It just knows, hey, I'm going to send this traffic to the foo service, and then it just sends all the traffic to the foo service, and Kubernetes decides how to load balance between the different pods. But Envoy actually supports this different mode that you can turn on in Emissary called endpoint resolving. So when you do that, Envoy actually just goes completely over the Kubernetes service, and it will go itself and figure out like what are the exact IP addresses of these pods, and that's what lets you do the more powerful load balancing algorithms to do more complex things other than just like a round robin load balance.
More complex, more powerful. I like powerful better than complex because more complex just sounds like you're introducing complexity for no benefit.
True.
More powerful than Kate's.
Yeah, it just sort of depends what your needs are, right? Like for small applications, maybe, the Kubernetes load balancer is perfectly fine, especially if you only have like one instance of your app. Like you don't even need the load balance, right? But if you've got like dozens of instances, or you want to do something with like sticky sessions, or like based on like the header, you want to like always send traffic with this certain header to the one instance that handled it first. You can do stuff like that with Envoy.
Cool. If I can make more room, if you want more room. I'm seeing like I bet I can make this into space. But if you think we're good, then I'll do a recap. What do you think?
I do want to talk about one more resource, if that's okay.
Yes. Bring it, Alice.
And it's one more of these service resources. This one is called the tracing service.
Okay.
So what the tracing service does is once you create one, it will tell Emissary to configure Envoy to start doing distributed tracing. And what that does is it will create a unique request ID header for every single request that comes in, or you can configure it to say like only do it on like 10% of requests if you don't want all traffic.
Yeah. So tell Emissary to configure Envoy to do distributed tracing.
Exactly.
How is this different? Aren't there projects that are just for tracing?
Exactly. So that's where the service part of it comes in, right? Is what we're doing tracing, and
Ah,
that's mostly just like creating traces themselves and doing sending the headers, right? And the service part says like, what tool do you want to use to receive these traces and visualize and store them? So that's where you just say like, my service for tracing is Zipkin or Jaeger or whatever your choice is.
so just like these other ones. Is it just like the other ones where you can point out a third party that does it and you can do it yourself? Or is
You
it
can
only
implement
point out a third
your own tracing service if you want, I think, but the driver needs to support one of the specific standards. So like an example of a driver is like the open telemetry driver, right? You could write your own tracing service, but it needs to implement a well-known driver standard. So say like, I want to use the driver for, Zipkin, and you just need to write your own service that supports the Zipkin standard or that supports the open telemetry standard. And those are like public APIs that they show you how to get started with those. But for a lot of people, it's totally sufficient to just set up, the Zipkin web UI themselves, and that's how you store and visualize all your traces. I'd say very few people probably want to implement that themselves.
Cool. All right. All
And
right. I'm
so,
feeling, yeah.
sorry, go ahead.
Yeah. No.
So once you've got like that header generated, Envoy will create a trace, and then when your service receives that header, it can do whatever it wants with it, like create logs or, propagate that trace up through any other services it talks to. And
Uh-huh.
then once that service is done, it'll send the response back to Envoy, and Envoy will say like, oh, this is that header I created for this trace. So I'm going to stop that trace, and now I'm going to bundle all the trace information up, send it to your tracing service so you can store that and visualize it, and then I'm going to send that response down to your downstream client. So tracing is like a really powerful way to figure out like what exactly is happening with this request over the course of its entire life cycle, from entering your cluster to talking to one app to potentially even having your app talk to other apps. And that way it lets you say like, okay, like, this is how long Envoy took to process this request, and here's how long my application took to process the request. Or you can even do cool stuff like if your app encounters an error, it can put that information about the error in the trace. So that way you can look up in your tracing service, like Zipkin, say like, show me all the traces that have this specific error in them. And it can say like, the trace was fine up until it hit this service. And then this service had an error and it reported that. So that helps you like pinpoint where things are breaking down or where there are bottlenecks or where there are problems in the whole pipeline.
Because once the traffic goes through an Envoy proxy, it gets a header, then it
Mhm.
goes to the app, and then inevitably there's a response that happens, which goes back to Envoy proxy, and then Envoy proxy sees the header,
Yep. It sees the header and then it stops the trace. It says, okay, this trace is done. And then it sends it off to
bundles.
the tracing service.
Cool. Awesome.
Yeah. And so each app needs to have support for the tracing, obviously. Otherwise, you just get a picture of what Envoy is doing and then not what your app is doing. But projects like OpenTelemetry make it really easy. And a lot of them will even just automatically do it. Just say, like, install OpenTelemetry, and depending on the language your app is using, OpenTelemetry is smart enough with a lot of languages to just automatically do all this tracing for you as a sidecar. Whereas other apps, you might have to import the tracing library and say like, oh, I received this header, store this information about the trace, and then finish.
Cool. That's amazing. Are you ready for a recap?
I'm ready for recap.
Okay. In the lands before time, before Emissary existed, There were Kubernetes. There's one Kubernetes native Ingress solution, but it was traffic and it was very simplified and not extremely powerful.
Yeah,
And it's
so
still around.
traffic actually is a good start for a lot of people, but traffic
Hmm.
focuses more on like intuitive decisions that it makes for you. It's very light on configuration, but it tries to just like do the right thing, TM, where it
Hmm.
just sees like, oh, like looks like you created a service with this sort of label. Like I'm just going to do all this sort of stuff for you. And so for people that are just getting started with Kubernetes, they're playing around, like just trying to figure out how stuff works, like traffic's probably
Uh-huh.
good enough for them. But when you actually want to have like full control over this sort of stuff and you're thinking about adding service meshes, you really need something a lot more powerful to give you total control over those sort of decisions, but also set smart defaults.
Nice. So you didn't have total control. And then we talked about what is an ingress. So I'm gonna write not the Kubernetes object. So an ingress is a piece of not the there is a Kubernetes object called ingress, and we're not talking about that.
No.
What we're talking about is this different definition of ingress, which before today I didn't know there were two definitions of ingress. This, which is a piece of software that solves a problem of getting traffic into and out of a Kubernetes cluster.
Mhm.
So when trying to untangle this, I thought maybe this was what an ingress controller is because I knew a Kubernetes object ingress needed a controller. And
Technically, that is, but a lot of people just shorten it to ingress.
so okay, so this is how I got the name Ingress because it once was an Ingress controller. But what I learned from you today is that um, projects like Emissary
Mhm.
make their own custom resources. So you're not actually using the Kubernetes ingress that you're controlling. You're controlling whole different objects that help simplify because an ingress is a big object and you're separating concerns by having different custom resources instead of using
Exactly.
the Kubernetes. So some ingress controllers handle Kubernetes ingresses, some handle their own completely custom resources like Emissary does, and some do both.
Mhm.
And so when you are choosing an ingress controller, let's say, there are lots of considerations. There are lots of choices and there are lots of considerations. So one thing you'll want to think about is scalability and performance. So make sure your ingress controller is not bottlenecking anywhere. It's ready to grow with your application. You need to think about traffic types considerations like HTTP and HTTPS are the most common, but there's a lot of other ones like HTTP3, proxy protocol, gRPC, WebSockets, and many, many more. So whatever you're using, you want to make sure your Ingress solution supports that. You want to make sure it has good security features, so it supports TLS, OAuth, rate limiting, etc. Traffic routing, so you want to support again all these same protocols for moving traffic around, and then also how is that getting into and out of and around the services in the cluster if you want to be switching your protocol, what's outside versus what's inside. um, and then traffic manipulation, so you might want to be adding headers, you might want to be rerouting, redirecting, your tracing is a good example of traffic manipulation. So those are things that you want to be thinking about when you're choosing an ingress. Now, Emissary-ingress is a self-service Kubernetes native API gateway. So what's cool about Emissary-ingress is that since you have separated that ingress objects into smaller objects that are more granular in scope, you can have an app friend, a developer, only have to manage the smallest amount possible to get done the things that they need to get done. So in this case, in Emissary Ingress's case, it's a mapping custom resource. So an
Exactly.
app friend only wants to worry about getting traffic to their own application. They don't care about anything else, and you
You know,
offer a solution for that.
another great example of why you would want this is that you don't want your app developers to be screwing up security concerns, right? So you can have your cluster operators manage those resources that deal with, TLS and deal with security. So that way you don't just have an app developer like letting in all sorts of traffic that's unsecured and whatnot like that because they just didn't know
Yeah.
what the goals were for how to handle it.
So it's not just about them being comfortable and efficient with their time. It's also about them
Keeping them
just
safe,
being
yeah.
safe. Yeah. And then the ops folks, So you want the app friend to have that great experience, but you also want the ops folks to have full control. So you don't want to sacrifice anything there. And that happens with Emissary-ingress. So then we started talking about emissary custom resources. So there are three big ones: the mapping, the listener, and the host. So the mapping is that object that the app friend is concerned with, and it controls where we're sending the traffic and if we're changing anything about that traffic. So where is it going, and does anything need to change? A listener configures what ports we listen on and what protocol we're listening for. So if it's listening for 8443 and it's listening for HTTPS, then if some other protocol comes in on 8443, it's going to ignore that. So it has rules about what it's going to send through. And then the host configures what host name you want to support, and you can do wildcards, and it also has the support for TLS, where you bring your own certificates, so you can use Cert Manager under the hood. I love Cert Manager for some reason. I just learned about it, so I'm putting my concepts together.
No worries. I use Cert Manager on like my own home server. It's awesome.
Nice. You're so cool. And then we talked about some smaller ones, but I'll save those to the end because they're more granular in nature, and I want to talk about the big picture some more. So we drew up our little cluster and what's going on about traffic coming in. So let's first talk about just traffic getting through to the app. It comes in through a load balancer. Well, we talked about it in terms of first to install Emissary, and then Emissary creates a load balancer, and then under the hood, the load balancer gets implemented probably by a cloud provider, or you can do it by hand if you're not on the cloud. So that's how the load balancer comes to exist. So the traffic comes in through the load balancer, and then it load balances between either instances of Emissary or really Envoy proxy, and between nodes. And so the load balancer, so Emissary lives in a container with Envoy proxy, and Emissary makes it much easier to configure Envoy proxy, which is so complex that humans aren't meant to mess with it directly. So the traffic comes in and gets through to Envoy proxy immediately, but it's been configured by Emissary, and then Envoy proxy knows to send the traffic through to our application. And maybe I said this, Emissary and Envoy proxy are two processes running in the same container. So then to configure Emissary very easily, that's where we have our mapping, listener, and host resources are running on the cluster. So they're human-friendly, they're persona-friendly ways to configure Emissary, which in turn configures Envoy proxy. So our example of that is 3 to 4 lines changing in a mapping resource might change 2,000 lines in Envoy proxy, and Emissary is what takes care of that for you. So basically, Emissary-ingress, we have two definitions for Emissary. Emissary-ingress is a self-service Kubernetes native API gateway, but Emissary is also basically a tool to manage and configure Envoy proxy. So an Envoy proxy is a reverse proxy. And then we talked about, we kept, like, the idea of service mesh kept creeping in on the edges. So I asked you what the difference between service mesh and Envoy and Ingress is. So service mesh manages traffic within the cluster, and then Ingress manages traffic getting into and out of the cluster, and that's the difference. And you talked about your other project, Envoy Gateway, which is a collaboration between many projects, like also Contour. I think you mentioned Linkerd, right? Maybe.
Yep, there's one guy from Linkerd who's very involved with just making sure like Envoy Gateway works fine and integrates well with Linkerd. And then we've got some folks from Tetrate and Tencent involved as well. There's a bunch of other projects, but those are the main sort of maintainers that are involved in the project.
So you're creating some base level tools and standardizations for any technology that plans on building on top of Envoy proxy to be able to use. So that's going to be ingresses and service meshes.
Yeah, the goal is for like Envoy Gateway to be its own like fully fledged ingress, just like Emissary is. But then, you know, Ambassador and all the other companies, I'm sure, that have open source ingresses, they want to make money off of them somehow. So you've got like your open source free to use ingress, and then like we build a product called EdgeStack on top of it, which is like we bring the authentication and the rate limiting for you. And so other companies want to do the same thing, and everyone's creating their own open source ingresses, and they're all like sort of competing. So the idea was like, hey, let's just have this one project where we get everyone involved, take the learnings and mistakes that we've made on our own projects, and provide like a common sort of core that anyone can use and get started with, and is also maintained by a broader group of people. And that way, if anyone wants to switch to any of these paid offerings, they can, because they'll all have that shared experience of working with Envoy Gateway, and the configuration language is the same across everything.
Amazing. And then finally, we talked about, so these emissary custom resources are only 3 that you might need to manipulate more often, but there are also many more that are more set it and forget it. So we talked about 3 more, but there are more than that too. So we talked about auth service and rate limit service. And so those basically point Envoy at an authorizer. It could be a third-party authorization service and a third-party rate limiting service, although you could always roll your own. And then so Envoy proxy will make sure traffic gets authorized through that third-party service before it gets sent through to your internal services, your internal applications.
Yep. And if it can't talk to it, then it'll just default to denying the request, so you're not letting unsecured traffic through.
It's great. And then it also integrates with, it helps with tracing. You can make a tracing service custom object that tells Emissary to configure Envoy to do distributed tracing by generating and watching a header that can be packaged up and then sent to a third party, like distributed tracing, like Jaeger.
Or
Yeah.
Jaeger, yeah. It gets a little confusing when you're just like, it configures Emissary to configure Envoy. That's really what's happening behind the scenes, yeah.
Yeah. But I think that's everything that we covered. Yeah. This has been so illuminating. It's been absolutely a dream. I've enjoyed every moment. Is there anything that you want to point out in closing, or maybe reiterate about how to join the community?
Yeah, there is a link that was shared in Slack by Whitney and the VMware crew. It's aar.io/Slack. And that is like the Emissary-ingress, like open source Slack community. So we've got a couple folks from like Ambassador there that are, just focused on answering community questions. And if you want to contribute to Emissary or get involved with the project, then the Slack is a great place to go, where you can talk to us, like the maintainers, and say you want to, submit a pull request, or you have questions about how to start developing on Emissary. You can totally just reach out to us there.
Awesome. Cool. Are you ready to dance it out?
Sure.
Yeah, it's the opening song.
Okay.
We're just gonna, let's see your moves. Heck yeah.
I'm not really good at dancing.
You're great. You're amazing. It's all about